Excellent. Okay. So before I get started, I'll tell you a bit about ENMAX. We're headquartered in Calgary, Alberta, Canada. We're a company with a vertically integrated utility with generation, transmission, and distribution assets in both Alberta and Maine. Let's see here. Now I'll tell you a bit about Alberta's interconnected grid. We average approximately 10 gigawatts of daily load. We're interconnected with 3 adjacent jurisdictions, British Columbia, Montana, and Saskatchewan. You can see the total transfer capability of those interconnects is roughly around 1,200 megawatts. Alberta imports a lot of generation over those interconnects. What's interesting about them, the BC tie line was constructed and became operational in approximately 1986. It was constructed without shield wires due to cost constraints at the time. Without those shield wires, it's very susceptible to tripping due to lightning strike. Now, Montana is also coupled with that BC intertie via a transfer trip scheme. So if the BC intertie goes out, Montana goes with it, exacerbating the problem. And when the province becomes islanded and we lose all that generation, we've had under frequency load shedding events leading to blackouts in some areas. And these have been increasing over time due to the changing generation mix within Alberta. I'll show you a slide later, but over the past few years, we've got completely out of coal-fired generation, and there's been a tremendous renewable build-out in the province. Right, I'll tell you a bit about the Crossfield Energy Center. This is an ENMAX facility that became operational in 2009. It's located approximately 50 kilometers or 30 miles north of Calgary, Alberta. Calgary is in the central part of the province. It's home to 3 48 megawatt General Electric LM6000 turbines. They burn natural gas and they operate in simple cycle operation. This is a peaking facility that we have. And it's home to Canada's first hybrid electric gas turbine. What is a hybrid electric gas turbine? Let's talk about the equipment. It's one LM6000 generator package coupled with a 10 megawatt, 4.3 megawatt hour lithium ion battery energy storage system. And then we have some very advanced digital control system that marries these two pieces of equipment together to be able to have functionality that neither asset alone could perform. The project was completed for $14.6 million, half of which was provided by Emissions Reduction Alberta. This is a government agency in Alberta that invests in new low carbon technologies. I've put a link to the project completion report. So if you'd like to check out more details, please feel free to check out the report. I have a quick video here that I'd like to show everyone. This explains how the hybrid electric gas turbine operates in the Alberta context. Let's see if we can get the video to work.
ENMAX is working towards a brighter, lower emissions future by implementing Canada's first hybrid electric gas turbine at Crossfield Energy Center. On an electricity grid, standby plants are always at the ready to provide electricity when there's an unexpected drop in supply or a peak in demand. However, these plants use fuel while they wait, similar to a car idle, and that produces emissions. By combining an existing natural gas turbine with a battery energy storage system, there's no need to use fuel all the time because the battery takes over on standby duty. The battery is always ready to go, and when there's a need to balance supply and demand on the grid, the battery meets that immediate need. If supply is required over a longer period, the battery delivers electricity until the natural gas turbine comes online and takes over. This hybrid solution not only reduces emissions, it also increases reliability by reacting in real time to balance the electricity system. This innovative technology can be applied to generation facilities throughout Alberta and beyond, and is a significant step towards creating a brighter, lower emissions future.
Right. Let's see that the video worked, but I seem to have lost the mouse. Okay. Okay, here we are. Okay. So in the video, they talked about standby plants. Okay. The technical term that we refer to in the electricity market is called spinning reserve. So when you think of the grid, there are a bunch of machines, as well as solar and wind, all producing power, putting that on the grid. But these machines break from time to time. And as we said earlier, the definition of reliability is when you turn the switch, the lights stay on. So spinning reserve is a product that market participants can offer within Alberta, where they reserve capacity such that they can provide it on the grid at a moment's notice, like it talked about in the video. So now I'd like to step through a comparison of a non-hybridized gas turbine with a hybridized gas turbine. In a slide earlier, I talked about how the nominal capacity of this gas turbine is 48 megawatts. In order to have that reserve capacity, the maximum amount of reserve capacity, we would run that gas turbine at its minimum stable generation, which is 20 megawatts. That would allow 20 to 25 megawatts of reserve capacity that we could offer to the grid. To do that, we have to burn natural gas, all right? And if we did that 24/7, 365 days a year, that would equate to 5,000 tons of CO2 being emitted. The battery in the hybrid allows the asset to be connected to the grid with the gas turbine off. Battery can react in real time, putting power on the grid in a moment's notice and long enough that we can start the gas turbine to provide more energy than the battery is capable of if we get called on by the grid operator. Here's what that looks like. That takes the minimum stable generation down to 0 megawatts. Now we have the full capacity of the gas turbine that we can sell as spinning reserve. Because we're at 0 megawatts and the gas turbine's offline, there's no emissions. It says near zero CO2 emissions. We do have to charge the battery, so it's not absolutely zero. We have two ways that we can charge the battery. We can either charge it from the grid at the grid intensity, or we can charge it from the gas turbine as well. Okay, let's talk about the grid benefits of a hybrid electric gas turbine compared to a non-hybridized asset. Typically, gas turbines provide primary frequency response when they're connected to the grid. This unit in particular has the ability to ramp at 10 megawatts per minute. Here's how the hybrid looks. It can provide primary frequency response from the battery alone without the gas turbine online. Its ramp rate, it can ramp the full 10 megawatts in less than a second. In doing that, it's able to provide fast frequency response. So when the tie line sheds, it can add those megawatts in an instant to the grid to help balance the frequency. It's capable of some modest voltage support with the GT offline. It's also black start capable. This slide, I talk about some of the benefits for ENMAX in developing this hybrid electric gas turbine. Number one, we're able to offer more spinning reserve. So this is the financial benefit, right? More spinning reserve equals larger offers, which equals increased revenue. The new asset is also more flexible than a gas turbine alone. It can operate in a pure gas turbine mode, it can operate in a hybrid mode, or it can operate as a standalone BESS or battery energy storage system. That flexibility allows for new revenue opportunities, once again, increasing the financial benefit to ENMAX. There's also cost reductions. I talked about being able to offer spinning reserve without burning fuel. So now we don't have to buy fuel to offer this product. We also don't have to pay the carbon emission costs associated with burning that fuel during the time. And with the GT offline more often, that also decreases our maintenance costs. This project, while it's the first of its kind in Canada, was completed twice before we took the technology to Canada. Those two installations were in California, performed by, it's on the next slide, it's coming up, San Diego, I believe. All right. This technology also helps mitigate the risk of a stranded fossil fuel asset in a decarbonizing world. We know the world is moving away from fossil fuels. This technology will allow this asset to persist longer than its sister assets on site. We talked about this earlier as well. This was the second installation of a battery energy storage system at a utility scale in Alberta. We had ENMAX engineers, operations, maintenance personnel who have all been trained on how to design this technology, how to implement, maintain, and operate. These are skills that are still emerging in the industry, and we've had a chance to train those individuals. Partnership, once again, Southern Cal Edison. That's who it was. This project would not have been a success if it wasn't for close collaboration with our partners here. I'll finish up with this slide. This first picture is a graph showing how the emissions intensity in Alberta has decreased over the past 6 years. It's essentially been cut in half. That's happened primarily due to two reasons. We're now out of coal-fired generation. And secondly, there's been that tremendous renewable buildup. When this project was started, there was only 15 megawatts of utility scale solar in the province. Now we have over 1,500 megawatts. We also had just under 2,000 megawatts of wind. Now we're approaching 5,000. So we're seeing the grid evolve in Alberta from a generation standpoint, but we still have this transmission line that's susceptible of tripping, right? And so we get back to resilience. The hybrid EGT is one piece of the resilient puzzle, but there are new and emerging technologies that people here in this room can help develop to help continue to lower emissions and minimize the impact for customers. Thank you.
Can I ask a point of clarification?
Yes, certainly.
Your cost reduction, did it include the cost of the battery and maintenance of that or not?
So for the cost of the battery, we did sign a long-term service agreement with GE, who was the provider. Certainly that is a cost. That's not a cost reduction though. Yeah. Any other quick question? Yes.
Why would you not charge the batteries like the solar power to the really further reduce the emission?
That's absolutely a possibility. We looked at, yeah, we have looked at that. That project wasn't, we weren't able to justify it moving forward, but absolutely there's the potential to do that.
I was assuming cost and land acquisition, all that may have played a factor there.
Absolutely. Yeah, we are somewhat confined in the amount of land for that facility, but we did still look at putting a small array there. Yep.
Okay.
you, guys.
One more?
Sorry, one quick question.
Okay, go ahead.
You mentioned that the battery can operate until the turbine starts.
Yes.
So can you give us a time duration how long time the battery can operate alone?
So it's 4.3 megawatt hours. So if we were to put 4.3 megawatts on the grid, it would last exactly for 1 hour with 100% state of charge. Typically, what we do is we keep the state of charge between 40 and 60% to minimize the degradation. So typically what happens is the battery will discharge to the grid, will immediately start the turbine. Within less than 5 minutes, the turbine is synced and it begins ramping up and the turbine and the battery starts ramping down.
Thank you.